This is SpaceTime Series 20, Episode 70. Coming up on SpaceTime. New theories on the formation of primordial black holes. Tabby Star probably just dusty rather than an alien megastructure. And how the world's biggest volcanoes formed. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mysterious long hypothesized objects known as primordial black holes may have made the universe the way it is today. The claims are based on two papers published in the journal Physical Review Letters, which speculate that these enigmatic black holes from the beginning of time formed before the first stars, and later helped create many of the heavier elements found in nature, such as gold, platinum and uranium. A long-standing question in astrophysics is whether the universe's first black holes came into existence in the hyperdense environment less than a second after the Big Bang, or whether they were formed only millions of years later, when the first stars in the universe began to die in powerful supernova explosions. The new research by UCLA Professor Alexander Kuzenko and grad student Eric Kotner suggests primordial black holes could have formed very shortly after the Big Bang, 13.8 billion years ago. Astronomers have previously suggested that primordial black holes could account for a significant percentage of the universe's dark matter, and may also have seeded the formation of the supermassive black holes now known to exist at the centres of most, if not all, galaxies. Kuzenko and Kotner began by speculating that some kind of uniform field of energy would have pervaded the early universe shortly after the Big Bang. Scientists expect that such fields existed in the distant past. And when the universe expanded during cosmic inflation in the first few moments after the Big Bang, this energy field would have separated into clumps. Gravity would then have caused these clumps to start attracting one another and merging together, with some becoming massive and dense enough to become primordial black holes. And just as importantly for the scientific method, if their idea is correct, astronomers should be able to find them by measuring the very tiny changes in a star's brightness caused by the gravitational lensing effects of a primordial black hole passing between the Earth and the star. In fact, earlier this year, astronomers published a paper on a discovery of one star in a nearby galaxy that brightened and dimmed precisely as it would were a primordial black hole passing in front of it. Meanwhile, in a separate study, Kuzenko and colleagues proposed that primordial black holes might play an important role in the formation of heavy elements, such as gold, silver, platinum and uranium. The origin of these heavy elements has long been a mystery to scientists. Kuzenko says scientists aren't really sure exactly where these elements are being formed. He says his research is suggesting that primordial black holes occasionally collide with neutron stars, those rapidly spinning remnant cores of stars that explode as Type II or core collapse supernovae. Neutron stars are incredibly dense objects, denser than anything else in the universe, that is, anything else other than black holes. So if a black hole collides with a neutron star, it would sink to the centre of the neutron star, and then begin consuming it from the inside out. Kuzenko says the process would probably take about 10,000 years. And as the neutron star shrinks, its angular momentum would increase, just as an ice skater spins faster when she draws her arms closer into a body. Eventually, the neutron star would be spinning so fast, small fragments of the star would detach and fly off. Kuzenko says those fragments of neutron-rich material that are being flung off the star may well be the sites where neutrons fuse into heavier and heavier elements like gold, silver, platinum and uranium. However, he admits the probability of a neutron star colliding with a black hole is rather low, which he says is consistent with observations that only some galaxies are enriched with heavier elements. The idea that primordial black holes collide with neutron stars to create heavy elements also explains the observed lack of neutron stars at the centre of the Milky Way, a long-standing mystery in astrophysics. Kuzenko and colleagues are now developing computer simulations designed to determine the types and likelihood of heavy elements really being produced in neutron star-black hole interactions. By comparing the results of those simulations with observations of heavy elements in nearby galaxies, the researchers hope to determine whether primordial black holes are indeed responsible for the Earth's gold, platinum, silver and uranium. You're listening to Space Time. I'm Stuart Gary. new analysis of a strange-looking star which is experiencing wild fluctuations in brightness indicates massive clouds of dust could be causing the phenomenon. The spectral type F white main sequence star KIC 8462852 first sprung to attention back in 2015 when citizen scientists looking through data from NASA's planet-hunting Kepler Space Telescope noticed abnormal cycles of dimming and brightening coming from the star. Kepler was designed to detect changes in stellar brightness caused by planets passing in front of or transiting their host stars. The star famously suddenly dropped in brightness by an astounding 22% over just a few days, and has also experienced more gradual fading of around 4% per year. The star was informally named Tabby Star after Tabitha Boyajian from Louisiana State University in Baton Rouge, who first studied the star's unexplainable flickering. Possible explanations for Tabby Star's strange behaviour have ranged from clouds of comets to the cataclysmic breakup of a planet. However, when one astronomer jokingly speculated that it could even have been caused by some sort of colossal alien megastructure such as a Dyson sphere surrounding the star, the tabloids went wild. Dyson spheres are giant theoretical structures big enough to encircle an entire star, drawing energy from it to power an advanced civilization. Of course, the mainstream mass media loved it, and so Tabby Star became famous. But despite all the speculation, astronomers have been hard-pressed to find a single explanation that adequately describes all the characteristics of this object. Now, a report on the pre-press physics website archive.org by a team led by Hugh Ming from the University of Arizona in Tucson suggests Tabby Star is dimming because of an orbiting cloud of fine dust particles. The authors use NASA's Spitzer Infrared Space Telescope and the ultraviolet sensors on NASA's Swift Space Telescope to study Tabby Star in detail. They found that the star was dimming faster at short blue wavelengths than longer infrared ones, characteristic of an environment of small dust-sized particles. It's the first time a multispectral image of Tabby Star has been undertaken. Meanwhile, a second paper on Tabby Star in the archive, this one by Joshua Simon from the Carnegie Institute in Pasadena, California, found a similar dimming while sifting through data from the All-Sky Automated Survey going back as far as 2006. Simon and colleagues also discovered that Tabby Star grew brighter in 2014 and also possibly in 2006. He suggests the sporadic brightening could be caused by the star's magnetic cycle in the same way that the sun's 11-year solar cycle affects the sun's luminosity. However, others have dismissed the hypothesis because the changes in the brightness are simply too drastic to be simply explained by a sun-like magnetic cycle. So, for now at least, the mystery remains. I'm Stuart Gary. You're listening to SpaceTime. Scientists have solved a 168-year-old mystery on how the planet's biggest and most active volcanoes were formed. The study, reported in the journal Nature, found that Hawaii's volcanoes formed along twin tracks due to a shift in the Pacific Plate's direction 3 million years ago. The study's lead author, Tim Jones from the Australian National University, says scientists had known of the existence of twin volcanic tracks since 1849, but their exact cause had remained a mystery until now. The new discovery helps better reconstruct Earth's history. Jones and colleagues' analysis of past Pacific Plate motions is the first to reveal that there was a substantial change in motion 3 million years ago. It helps to explain the origins of Hawaii, Earth's biggest volcanic hotspot. The twin volcanic tracks emerged because the mantle plume was out of alignment with the direction of the plate's motion. Twin volcanic tracks also exist in other parts of the Pacific, including Samoa, and the study found that these also emerged about 3 million years ago. Jones says this kind of volcanic activity was surprising because it occurred away from the tectonic plate boundaries where most volcanoes are found. Heat from the Earth's core causes hot columns of rock called mantle plumes to rise almost 3,000 kilometres from the Earth's core mantle boundary to the tectonic plates on the surface, producing volcanic hotspots. A volcanic chain's then created as the tectonic plates move over the hotspot. Mantle plumes are important because they've played a role in mass extinctions, the creation of diamonds, and the breaking up of the continents. Jones and colleagues hypothesized that the plate and the plume will realign again sometime in the future, and the two tracks will merge to form a single track once again. Tectonic plate shifts have been occurring constantly but irregularly throughout Earth's history. Looking further back in time, scientists have found that double tracks aren't unique to young Hawaiian volcanism and coincide with other past changes in plate motion. Hawaii sits at the southeastern limit of a chain of volcanoes and submerged seamounts, which gets progressively older towards the northwest. Jones used the ANU's National Computational Infrastructure to model the Pacific Plate's change in direction and the formation of the twin volcanic tracks through Hawaii.
The research is on the Hawaiian volcanoes, a specific aspect of those volcanoes, which is a mystery that's been known to Earth scientists for over 150 years now. And that is that at about 3 million years ago, we see the Hawaiian chain as a single track of volcanic islands. And then we see it split into two parallel tracks of volcanoes. And that's the part that no one's really known why. We actually started to see these all over the globe, and in fact, many of them on the Pacific Plate. And that led us to believe that there is a much larger process that's occurring that is generating these kinds of volcanic tracks, because in fact they all emerged at roughly the same time. So it's that simultaneous timing and their widespread location over the Pacific Plate that really tipped us off that there is a much larger scale process. So what we know about Hawaii is that it's above something called a mantle plume, which is essentially a column of hot, buoyant rock. And as that rises through the Earth's mantle, that's the rocky layer between the crust and the Earth's core. The core is essentially driving heat off itself constantly. That heat is causing the rock above it to heat up and rise to the surface. As it gets close to shallow enough pressures, it begins to melt and generate island chains like Hawaii. Because they remain relatively fixed, plates are allowed to move over the top of them, and that creates a linear chain. What we did was essentially model what is happening beneath Hawaii by creating a simulation of the Earth of this hot, buoyant mass rising from the core to the surface. And what we found was that it interacts with plate motions in an interesting way. What we found is that as the plates above shift, they can cause these two twin tracks to emerge across the overlying plate.
How would that work? We've got this one track, it's caused by a mantle plume hotspot, and all of a sudden the plate changes the way it's moving, and so the first hotspot is still there, the original one, and then gradually a second one veers off from it to one side.
Yeah, it's nearly what it is, but it's slightly different. It's actually a single, what we call hotspot, that is controlling the whole process. What's happening is that within that hotspot, there are two different components, and those components melt at slightly different pressures and temperatures. And so because of that, you have these sort of separated magma chambers that are erupting. Now, as the plate moves in one direction, what's been happening for a very long time is that those magma chambers have been erupting along the same location. Essentially, some lava will erupt at the surface, and then lava from the next magma chamber will overprint those lavas. And so it wasn't clear that there was two beneath Hawaii. It wasn't until the plate changed direction that it allowed those two magma chambers to be exposed as two geographically separate tracks.
The two tracks were on the same line originally, but then when the plate movement changed direction, that caused that original alignment to split apart, split sideways.
Yes, exactly. It's the misalignment that is exposing them, and that's what we are linking this process at the surface to much deeper within the Earth.
Had the Pacific Plate not changed direction 3 million years ago, we wouldn't have known there were actually two separate hotspots at that location.
Yes, exactly. And what's happening is that the underlying hotspot is realigning to the new direction of the Pacific Plate motion. So because the plate is essentially dragging the underlying material with it, the underlying hotspot requires a period of adjustment about which it will sort of rotate to come back in line with the Pacific Plate's new direction. And that will mean that these two twin tracks will eventually converge again onto a single track. So in the future, millions of years from now, the two tracks will become one once again.
So that must be telling us something new about the way hotspots are formed and how they interact with the mantle and crust above them, the lithosphere above them.
Yeah, it's telling us that we can get complex patterns in the surface expression of hotspots from very simple large-scale processes. It makes the Earth a lot more interesting than we previously thought in this specific way.
Now, we're talking specifically here about the Pacific plate. How does that affect nearby plates, others around it? Does it simply subduct underneath so it's no big deal, or does it cause changes in tectonic plates all over the planet?
It will affect the forces that are related between each of the plates all around the world. Whether or not that will manifest as a change in direction or maybe a speed up or a slow down in other plates like the Australian plate is unclear. It could certainly lead to that, but it depends on the specific interaction. What we can do now that we know that the Pacific plate has changed about 3 million years ago, is we can look at other plates around about that time and figure out if there was a change there as well, and whether or not that change is associated with what's happening in the Pacific, or maybe other changes were causing everything. It's not clear at this stage.
We have our own volcanic hotspot track here in Australia called the Cosgrove Hotspot Track. It's about 33 million. Yes, it's about 33 million years old, about 2,000 kilometres in length, and based on its movement, we should have a hotspot somewhere around Bass Strait at the moment, but which we haven't actually found yet. But I take it the idea now will be maybe we have to look in a slightly different location to see exactly where that Bass Strait hotspot point would be, if it indeed is there.
Yeah, we need to look in a reasonably wide location, and that's because we know roughly around the Bass Strait, but we also know that as these things rise, they can drift quite far away from their initial rising point, and so it's difficult to say exactly where that hotspot will be. In addition, whether or not it generates a volcano at the surface depends heavily on what the structure of the Earth's crust is above it. Sometimes there just isn't a pathway for the magma to rise through, and sometimes the pressure that the magma places on the Earth's crust isn't large enough to drive its own pathway.
Well, they found that with Cosgrove as well, didn't they? There were some places the crust was just too thick to make its way through.
Yeah, that's right. In areas, the crust is so thick that it exceeds the pressures at which the rock in the Earth can actually melt. So it's forcing it to be at much higher pressures where melting won't occur.
This is adding a new page to our understanding of how mantle plume hotspots form and evolve over time.
Yeah, it is. It's allowing us to link their behaviour to something we can actually observe at the surface. It's a very tricky business looking at these things because we essentially have few images. And when I say images, what we have is detected that the seismic waves that move through the Earth because the plates are rubbing up against each other and generating earthquakes, as those travel through these hotspots, they slow down because they're very hot, and these waves travel slower through hot material. And so we can build up a kind of picture like you would if you had an ultrasound from these seismic waves, but they're very rough sketches. They're not very precise, but earthquakes don't occur exactly where we want them to.
What's your next plan in this particular project?
So the next plan is to look elsewhere where these double tracks have emerged, and also to look back in time at much older hotspot tracks and try to figure out where we see glimpses of these double tracks, because we know that they should emerge and then disappear again. And so if we can pinpoint where they are elsewhere, we can date those rocks to figure out the timing, and we can link them back to past changes in plate motion. That's going to help us reconstruct the tectonic history of the Earth, which is figuring out Earth's history, figuring out how we got from the past to the present is a lot of what earth science is about.
That's Tim Jones from the Australian National University. Just a few years ago, geologists discovered the world's longest chain of continental volcanoes, stretching over more than 2,000 kilometres along what is now eastern Australia. The ancient volcanic chain runs from Cape Hillsborough on the central Queensland coast, southwest through central New South Wales to Cosgrove in Victoria. The chain's nearly 3 times as long as the famous Yellowstone Snake River hotspot tracks on the North American continent. It was created over the past 33 million years as the Australian plate moved north-northeast over a mantle plume hotspot now located in Bass Strait. The track's being named the Cosgrove Hotspot Track after an extinct Victorian volcano in the chain. The newly identified volcanic chain is the most westerly of 3 major volcanic chains running along eastern Australia. Scientists reached their conclusions by examining 15 extinct volcanoes in eastern Australia which appear to be following the same general track. The volcanoes showed an age progression, getting younger the further south they were. And just as importantly, they matched the movement of the Australian tectonic plate. Scientists used seismology to map the thickness of the Earth's crust and mantle, finding that the volcanoes in Queensland erupted through lithospheres around 80 kilometres thick, while those in New South Wales and Victoria melted through lithospheres around 100 kilometres thick. There was a gap between the Queensland volcanoes and those in New South Wales and Victoria, which appears to have been caused by the lithosphere in this region being more than 150 kilometres thick, thereby preventing the mantle plume from melting through. The differing thicknesses of the lithosphere also explain differences in the chemical composition of the volcanic rocks found at different locations along the track. Based on the speed at which the Australian plate's now moving, the mantle plume which generated these volcanoes would now be located below Bass Strait, between King Island and the Tasmanian mainland. Researchers are now trying to determine if the lack of a volcano at the plume's current location is caused by the thickness of the lithosphere there. You're listening to Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. An Indian rocket has failed to place a new navigation satellite into orbit after the payload fairing failed to separate during the launch. The PSLV C-39 mission blasted off normally from the Satish Dhawan Space Centre on the Bay of Bengal coast, carrying the IRNSS-1H payload, the eighth satellite for the Indian Regional Navigation Satellite System. The launch began smoothly, with the PSLV fitted out in its XL configuration, which includes 6 strap-on boosters.
Authorizes for initiating automatic launch sequence for PSLV C-39 IRNSS-1H mission. ALC Roger.
So vehicle director has just authorized the initiation of the automatic launch sequence. We have a total launch window of around 10 minutes.
Minus 55 seconds. All stops are on. All sequences are on.
So minus 40 seconds for launch.
Mission key lock enabled. Real-time programs activated. Minus 25 seconds. PS2 VSPPs are opened. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, plus 2, plus 3, plus 4, plus 5,
So
plus 6,
PSLV lift
plus
off.
7,
Lift off
plus
normal.
8, plus 9,
PSLV
plus
lift
10
off
seconds.
normal. Ignition of the solid core booster and 4 solid strap-ons.
Plus 20 seconds.
So 20 seconds into the
First
flight.
stage performance normal.
Plus
First
25
stage
seconds.
performance has been declared as normal. The air lead strap-on has been successfully ignited in 25 seconds. So 40 seconds into
First
the
stage
flight.
performance normal.
It lifted off on time, and all systems and sequences appear to occur just as scheduled.
So at 70 seconds, you will have the separation of the ground lead strap-ons, where the vehicle altitude would be roughly around 24 kilometers.
Plus 1 minute.
So we're already 60 seconds. The performance of the first stage,
Ground lead
yes,
strap-on
ground lead
separated.
strap-on has been successfully separated at 70 seconds. The next important event will be the separation of the
change route, SCBT
air lead
1.
strap-on at 92 seconds. The performance of the first stage has been normal.
Air lead strap-on
Air lead
separated.
strap-on has been successfully separated in 92 seconds. And as far as the altitude of the vehicle is concerned, it's an altitude of around 51 kilometers and the velocity is around 2.01 kilometer per second. The first stage of the rocket has been successfully separated
First
at
stage
109
separated.
seconds.
Second stage
And the second
ignited.
stage has been successfully ignited at 109
Plus
seconds.
2 minutes.
So just waiting for the announcement from the range operation director for the nominal performance of the second stage.
Second stage performance normal.
Yes, second stage performance is normal, and during the second stage of flight, the closed loop guidance has been algorithm has been initiated. Right now we are at 145 seconds, exactly at the 203 seconds when the vehicle reaches an altitude of 115 kilometers. You will have the announcement for separation of the payload fairing.
Second stage performance
6
normal.
kilometers per second, and the range the vehicle has traveled is around 205 kilometers now. So second stage performance is normal. Altitude of around 115 kilometers, very close to the announcement for the payload fairing separation. As for the nominal timing, at 203 seconds, we should have the separation of the payload fairing.
However, the call-out indicating separation was never made, and the faces of those in the Mission Control Centre began to look sombre, with an air of concern beginning to take hold.
What they're taking the vehicle in Minato.
So 240 seconds into the flight, the velocity is around 4.33 kilometers per second. Altitude is 131 kilometers. The second stage cutoff is expected at 260 seconds, when the vehicle would have been at an altitude of 134 kilometers.
Second stage engine shut off.
Second stage has
Third
been
stage
successfully separated at 263 seconds, and the third stage has been ignited at 264 seconds. So velocity of the
Third
vehicle,
stage performance normal.
the velocity is around 5 kilometers, and the vehicle has crossed a range of almost 658 kilometers. The third stage of the rocket, which is the PS3 stage, will burn for nearly 120 seconds. After its burn out, the vehicle
5
will
minutes.
continue to progress
Third stage
further
performance normal.
before the fourth stage gets ignited after 230 seconds. So there will be a coasting time of around 230 seconds between the third stage burnout and the fourth stage.
Third stage performance normal.
So third stage performance normal. The vehicle is an altitude of around 138.5 kilometers.
Third stage action completed. Vehicle in coasting phase.
So third stage burnout, the vehicle is going through the coasting phase right now, and as far as the ignition of the fourth stage is concerned, it should happen at 616 seconds in place
Vehicle
of activities.
coasting normal.
We have a very close match of the pre-flight prediction of the ground trace versus the flight conditions.
As the mission's ascent continued, the launch vehicle began to slowly vary off the planned flight path, with both altitude and velocity starting to fall short of targets.
And as far as the time versus altitude is concerned, a very close match with respect to the performance of the pre-flight. PS4 burning is for nearly 500 plus seconds, and after the PS4 ignition, you will have the burnout of PS4 stage at around 1128 seconds.
PS4 engine started.
PS4 engine ignition has been ignited. The time right now is 575 seconds, and the vehicle has reached a velocity of around 7.15 kilometers per second, the range of around 2,600 kilometers. The altitude is around 152 kilometers, and the range is nearly 2,670 kilometers. The velocity is around 7.2. The vehicle has attained an altitude of around 155 kilometers now. We're just awaiting the announcement from the range operation director to confirm of the performance on the fourth stage.
It soon became clear that the added weight caused by the payload fairing failing to jettison was retarding performance.
To reach an orbit of around 284 km perigee and 20,600 km apogee, we would require a velocity of nearly 9.6 km per second. So right now we are at 7.5 km per second velocity. So there has been a variation in the performance from the pre-flight prediction as of now. The velocity that will be required to reach the final destination orbit will be 9.7 km per second. Velocity of just 8 km per second right now, and altitude is around 232 kilometers. Now I'm waiting for the final clearance from the range operation director in terms of the performance. As far as the perigee and apogee is concerned, they are lower than the predefined number at this instant of time. The velocity is around 8.3 km per second. Just awaiting the confirmation from the range operation director. So PS4 shutoff command has been issued at 1039 seconds. And as per the display screen on the flight events, IRNSS 1H satellite separation command has been issued as 1076 seconds. So we are waiting for the announcement from the range operation director. And the perigee and apogee is around 167 by 6,554 kilometers.
The fairing still being in place would also ultimately prevent the satellite's deployment.
This is the range operations director. During the flight, heat shield has not separated. Further analysis will be carried out subsequently.
The launch was the 41st flight for India's PSLV workhorse. The Indian Space Research Organisation has launched a full investigation into the cause of the failure. We'll keep you informed. This is Space Time. I'm Stuart Gary. The Soyuz MS-04 capsule, carrying 3 Expedition 52 crew members, has successfully returned to Earth after 135 days in orbit.
The Soyuz MSO4, under its main chute and the nominal venting of hydrogen peroxide from the thrusters, everything is in great shape. We should be seeing the jettisoning of the heat shield that will expose the altimeter that will provide altitude and rate of descent information to the Soyuz's computers. Everything is in great shape, just 11 minutes until touchdown. Peggy Whitson, Jack Fisher, Fyodor Yurchikhin, and there is the jettisoning of the heat shield right on schedule. On a Sunday morning, less than an hour after sunrise, the Soyuz MSO4 gliding to its landing site, everything in great shape. The crew has been in contact now with the search and recovery forces. About 8.5 minutes until touchdown, the Soyuz gently descending under its main parachute. The Soyuz launched with just 2 people on board, Yurchikhin and Fisher, back on April 20th, coming home with Peggy Whitson. Everything proceeding on track. Temperature at the landing site about 77 degrees Fahrenheit under crystal clear skies, greeting Yurchikhin, Fisher, and Whitson home from the International Space Station. Just a few feet off the ground, there'll be a firing of the Soyuz's soft landing engines, one final braking maneuver before touchdown. Search and recovery forces and the Russian Mi-8 helicopters are in a racetrack pattern around the landing site, ready to form a welcoming party for Yurchikhin, Fisher, and Whitson as soon as they touch down. Landing schedule just over 4 minutes from now. All of the entry milestones have unfolded in trip hammer fashion, in great shape for the Soyuz spacecraft and its occupants. Just about 2.5 minutes until touchdown. You can hear the sound of the radio beacon on the Soyuz spacecraft, very audible and very clearly heard by the search and recovery forces. And one of the Russian Mi-8 helicopters in the foreground. Just seconds away from touchdown now. Peggy Whitson, Fyodor Yurchikhin, and Jack Fisher are about to return to terra firma. Touchdown confirmed at 8:21 p.m. Central Time, 9:21 p.m. Eastern Time.
The spacecraft touched down under the canopy of a massive orange and white parachute in clear blue skies on the windswept Kazakhstan steppe.
Simply spectacular from chute deploy to touchdown. The Soyuz MSO4 and its 3 occupants, Peggy Whitson, Fyodor Yurchikhin, Jack Fisher, back on Earth. The all-terrain vehicles and the initial search and recovery helicopters will now begin to make their way towards the Soyuz spacecraft to begin the process of safing the vehicle and extracting the crew.
Peggy Whitson's return to Earth wrapped up a record-breaking flight, which saw her spending 288 days in space on this mission, in the process boosting her total days in space to 665, more than any other American astronaut, and just short of Russian cosmonaut Fyodor Yurchikhin's own record of 673 days over 5 missions. The 3 crew members remaining on station will be joined by 3 new Expedition 53-54 crew who are slated to launch aboard the Soyuz MS-6 spacecraft from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan on September 12. This is Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. And a new study claims adults who have poor sleeping patterns are more likely to be overweight or obese and have poor metabolic health. The findings, reported in the journal PLOS ONE, showed that people who were sleeping an average of 6 hours a night had waist measurements some 3 centimetres greater than individuals getting 9 hours of sleep a night. And the less sleep a person averaged, the larger the waistline. The results strengthen the evidence that insufficient sleep could contribute to the development of metabolic diseases such as diabetes. The study involved 1,615 adults who reported how long they slept and kept records of food intake. Participants had blood samples taken and their weight, waist circumference and blood pressure recorded. The number of people with obesity worldwide has more than doubled since the 1980s. Obesity contributes to the development of many diseases, most notably type 2 diabetes. So understanding why people gain weight has crucial implications for public health. Shorter sleep was also linked to reduced levels of HDL cholesterol in participants' blood, another factor that can cause health problems. HDL, or high-density lipoprotein, is good cholesterol that helps remove bad fat from circulation. In doing so, high HDL cholesterol levels help protect against conditions such as heart disease. A new study is warning that tropical cyclones will get worse in the Pacific because oceans are warming due to climate change caused by dramatic increases in man-made greenhouse gases. The findings, published in the journal Science Advances, are based on a study comparing the formation of more than 850 past cyclones, typhoons and hurricanes in the western Pacific Ocean over a 60-year period. Researchers found that the intensity of a cyclone was largely dependent on the temperature of deep seawater, which gets churned up as the storm passes overhead. Slightly warmer waters, 50 to 150 metres deep, bolstered stronger storm seasons. Projecting this finding into the future, the researchers predict that Pacific warming will strengthen future storms, increasing peak wind speed by 14%. Tropical cyclones, hurricanes and typhoons, they're all different names for the same thing, are ranked in terms of category by their wind speeds. And the predicted increase in wind speeds through global warming is enough to turn Category 3 storms into Category 4. That's the difference between a storm considered devastating and one that's catastrophic, with a 50% increase in destructiveness. Since the mid-1970s, average cyclone intensity has risen more than 10%, and subsurface waters over that same time frame have warmed by about 0.75 degrees Celsius on average. Worse still, climate change is expected to warm these subsurface waters by at least 1.3 degrees Celsius more by the year 2100. And that will result in the average cyclone wind speed increasing from 198 to 225 kilometres per hour. North Korea has confirmed that an earthquake detected throughout the North Asian region was actually a successful test of a hydrogen bomb capable of being fitted on an intercontinental ballistic missile. The announcement follows the detection of a magnitude 6.3 earthquake centered near Punggye-ri, the site of last September's nuclear test in the rogue state's northeastern region. The initial blast was followed by a smaller magnitude 4.6 aftershock, thought to be a structural collapse caused by the initial explosion. Based on the strength of the earthquake, this latest test would have yielded between 50 and 60 kilotons. That's about 11 times stronger than North Korea's nuclear test in January last year, and up to 6 times stronger than its last nuclear test in September last year. The latest test follows a series of 13 intercontinental ballistic missile tests by Pyongyang so far this year. These have included ICBMs with a range of over 10,000 kilometres, putting the mainland United States within range. North Korea is thought to have at least 10 rudimentary nuclear bombs and has spent decades trying to perfect the long-range missile delivery systems needed to carry these weapons, claiming it was all part of a space program to launch satellites. Shortly before the latest test, the state-run Korean Central News Agency released photos of the communist nation's dictator Kim Jong-un inspecting what Pyongyang describes as a hydrogen bomb capable of being attached to a missile. In response to the latest nuclear test, South Korea has called an emergency National Security Council meeting and placed its military on high alert, while Japan's Prime Minister says he would not tolerate another nuclear test. For its part, the United States has begun flying radiation monitoring aircraft over the area. However, Moscow claims radiation levels appeared to be remaining at normal background levels in the Russian Far East following the North Korean test. Kim Jong-un has now hired a team of former KGB bodyguards for close personal protection amid growing fears of plans in the West to resolve the issue by euphemistically cutting off the head of the beast. As to what really happens, only time will tell. Scientists have discovered human footprints on Crete dating back some 5.7 million years. The findings by anthropologists from Uppsala University challenge all previous research, which has shown humans at the time still had ape-like feet and were still evolving in Africa. Ever since the discovery of fossils of Australopithecus in southern and eastern Africa during the middle of the 20th century, the origins of modern-day humans, Homo sapiens, were thought to lie in Africa. More recent fossil discoveries in the same region, including 3.7 million-year-old footprints from Tanzania, which show human-like feet and upright locomotion, have cemented the idea that hominids not only originated in Africa, but remained there for several million years more before beginning their migration to Europe and Asia about 70,000 years ago. Human feet have a very distinctive shape, different from all other land animals. In fact, the feet of humans' closest relatives, the great apes, look more like human hands than human feet. The Tanzania footprints, thought to be made by Australopithecus, are quite similar to those of modern humans, except that the heel is narrower and the sole lacks a proper arch. By contrast, 4.4 million-year-old footprints from another hominid species, this one found in Ethiopia, and thought to be the oldest known hominid from reasonably complete fossils, has a rather ape-like foot. The researchers who described that discovery argued that it was a direct ancestor for later hominids, implying that a human-like foot had not yet evolved by that time. And that's why these new footprints from Western Crete are so unusual. They have an unmistakable human-like form. This was especially true of the toes, the big toe being very similar to modern Homo sapien in shape, size and position. The foot's also associated with a very distinct ball on the sole, which has never been present in apes. This all conflicts with the hypothesis that Australopithecus is the direct ancestor of later hominins. Furthermore, until this year, all fossil hominins older than 1.8 million years came from Africa, leading most researchers to conclude that this was the place where the group evolved. During the time when the Crete footprints were made, the Sahara Desert didn't exist. Instead, it was a savanna-like environment extending from North Africa all the way up around the eastern Mediterranean. And as for Crete, it was still attached to mainland Greece at this time. And finally for now, more good news for chocolate lovers, with a new study showing that dark chocolate enriched with extra virgin olive oil is associated with an improved cardiovascular risk profile. A healthy diet's known to reduce the risk of cardiovascular disease. Fruits and vegetables provide protective effects through plant polyphenols, which are found in cocoa, olive oil and apples. Scientists from the University of Pisa in Italy tested the association between the consumption of dark chocolate enriched with extra virgin olive oil or Panaya red apples in healthy individuals with cardiovascular risk factors. The randomized study included 26 individuals with at least 3 cardiovascular risk factors, such as smoking, hypertension, or a family history of cardiovascular disease. Each subject was given 40 milligrams of dark chocolate daily for 28 days. For 14 consecutive days, it contained 10% extra virgin olive oil, and for the other 14 days, it contained 2.5% Panaya red apples. 2 types of chocolate were given in random order. Progression of cardiovascular disease was assessed by metabolic changes, lipid profile, blood pressure, and levels of circulating endothelial progenitor cells, which are critical for vascular repair and maintenance of endothelial function. After 28 days, researchers found that chocolate enriched with olive oil was associated with significantly increased endothelial progenitor cell levels compared to both baseline and after the consumption of apple-enriched chocolate. Olive oil-enriched chocolate was also associated with significantly increased high-density lipoprotein or good cholesterol levels and decreased blood pressure compared to baseline. Scientists did notice a very slight decrease in triglyceride levels with the apple-enriched chocolate. The research suggests that extra virgin olive oil might be a good food additive to help preserve our repairing endothelial progenitor cells. Yay for the chocoholics! This is SpaceTime. I'm Stuart Gary. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.